Hi, welcome back. Here's our next example of a normal problem. We're going to follow our 6-step process. So our first step is interpret and define. I'm going to read it, highlight things that are important, and define my random variable x. A mandatory competency test for high school sophomores has a normal distribution with a mean of 400 and a standard deviation of 100. The top 3% of students receive $500. What is the minimum score you would need to receive this award? The bottom 1.5% of students must go to summer school. What is the minimum score you would need to stay out of this group? So it looks like I'm going to be using an area to go to an x value, but I know for sure I'm going to be using a normal model. Okay, so I'm looking at test scores. So my x value is going to be a student's score on the competency test, on the high school competency test. And our units are really just score. We don't have any units, so I'm going to decide that my units are actually score. So now check, is it a normal model? Well, they tell me it's a normal distribution, so I may use a normal model. So I've checked parameters. The mean of this model, when I read, it told me the mean is 400 and the standard deviation is 100. Really important that we identify all of this information and put it at the top of our paper in a clear, easy to see place. Then we're going to move on to draw, calculate, translate, and each step of the problem will have these 3 steps. So the top 3% of students receive $500. What is the minimum score you would need to receive this award? So when I read this problem, the number 500 stands out to me because I like $500, but this is kind of a misleading number. It's not directly a part of my problem. It's the prize that you can win, but this is what I'm actually looking at, those 3% of students. So I'm going to draw my normal model, and I always start by drawing my normal model and labeling it appropriately. So there's my normal model. It is centered about 400, that's its mean. I've labeled it x is approximately normal with a mean of 400 and a standard deviation of 100. The top 3% of students. So this area here is 0.03, and I want to know what that value is. I want to know what score do I have to earn to get that. So for this particular step, I'm going to go through this one the long way and the short way. So the long way is that I'm going to draw another axis, that's my z-axis, and I'm going to find my z value. And once I have my z value, I can calculate my x value from it. So I can use my calculator to find the z value or the table. So ZA is equal to inverse norm. Inverse norm. Inverse norm requires area to the left. I know area to the right. Don't get tripped up and think that this is what you should put in. We want 97% as the area to the left. So 0.9701. So that gives me 1.88 as my z-score. So that means my x value is equal to the mean plus the z value multiplied by my standard deviation. So that is 400 plus 1.88 times 100. That is 588. Okay, now I'm going to do this the short way. So instead of going through all of this math, I'm going to say that my x value is equal to inverse norm of 0.97, but instead of using 0 and 1 as my mean and standard deviation, I am going to use 400 and 100, the mean and standard deviation for this problem. And I get 588. So I get the same answer both ways. This was so much faster and easier. So I'm gonna tend to stick with this problem. Okay, so now I've done my calculations. Next, I need to translate. How am I gonna tell someone what this means? So, a student must score at least a 588 to receive $500. That is my interpretation in context. So if your score was 588 or higher, congratulations, you won $500. In part B, the bottom 1.5% of students must go to summer school. What is the minimum score you would need to stay out of this range? So again, a normal model. And I don't know the X value again. In this area, the bottom 1.5% of students, so as a decimal, that is 0.015. I find that people have a lot of trouble converting 1.5, 3.2, things like that into percents. So 0.015 is what that turns into. I'm going to solve this the easy way. I'm not going to go through all of this process. I'm just going to do this. So XB is equal to inverse norm of 0.015 because 0.015 is the area to the left. Remember, 0.03 was the area to the right, so 0.97 was the area to the left. We already know the area to the left. 400, 100. So going to my calculator, 0.015, 400, 100, 182.99. So I'm going to say that's about 183. So a student must score at least 183 points to not go to summer school. So that means if you scored 182 points or less, you have to go to summer school. So we went through the 6-step process, making sure that we put our answers into context that people can understand.